Hello friends, welcome to our channel Engineering and Technology for You. In today's video, we will learn about the PIC 18 family programming model. Let us start with the introduction. The programming model of PIC 18F MCU is divided into two major groups of registers. Registers in arithmetic and logic unit, that is ALU, and the registers in data memory called the special function registers, SFRs. Now the programming model includes the working registers, WREG, then flag register, status, file select register, FSRs, then multiplication register, program counter, stack, and special function registers, SFRs. Let us see each of them in details now. Now, the first, you can see the diagram here. These are the ALU and associated registers, WREG, working register. Then with that, we have the instruction decoder, status register, then this BSR, and there is nothing but the bank select register, and then these are the FSR, file select registers. Then we have the program counter, which is 21 bit, then table pointer, stack pointer, and on this side we have the special function registers, that is for IO ports, interrupts, EEPROM, then serial IO, then timer, CCP, then A to D converter, synchronous serial IO, and miscellaneous functions. So that will be starting from F80 to FFFH in the data memory. So we'll see the details of each of them. Now first is the working register. The working register, or WREG, is a 8-bit in the arithmetic and logic unit and is used for all arithmetic and logic operations. It is used by many instructions as a source of an operand. It also serves as a destination for result of instruction execution. It serves functions similar to that of an accumulator in many microcontrollers. So it's a 8-bit register. Now here we have shown D0 to D7. This is the 8-bit structure of the working register. Then let us go to the next register, that is the bank select register, BSR. Now it's a 8-bit register but uses only 4 bits to specify the data bank from 0 to F, and upper 4 bits are always 0. Then the address map for data register ranges from 000 to FFF, that is, it has got 4096 addresses, and the entire map is divided into 16 banks 0 to F. Each bank has 256 registers 00 to FFH. Then in indirect addressing, the bank select register BSR provides 4-bit address that is combined with 8-bit specified in the instruction, resulting in a 12-bit address. So here you have to remember that only 4 lower bits are used and 4 upper bits, they will be always 0 for the bank select register. Then the next is status register. Status register is an 8-bit but uses 5 individual bits B0 to B4 called flags, reflecting the status of operation. Remaining bits are not used. As you can see here, these are the 5 bits which are used, B0 to B4, and these are not used. Then we have the carry flag, then this is the digital carry flag, then 0, overflow, and sign. Let us see each of the flags. The carry flag is set to 1 when addition generates a carry and a subtraction generates a borrow from the MSB of the result. Otherwise it is reset. Then the next flag is digital carry flag. Digital carry or DC flag is set when carry is generated by bit 3 to bit 4 in arithmetic operations. So generally it is used in the BCD operations. Then the 0 flag is set when the result of an operation is 0, otherwise it is reset. Then overflow flag, the flag is set when the result is outside the range of signed numbers. So it is concerned with the signed arithmetic. If the result is outside the range, then it will be set, otherwise it is reset. Then the last flag is negative flag, or it is also called as the sign flag. Indicates the status of MSB, that is the most significant bit D7 of the result of arithmetic and logic operation. If bit D7 is 1, this flag is set, otherwise it is reset. So if it is 1, then it shows the negative result. So this is all about the flags. Then let us go to the file select registers, FSR. Now there are 3 registers, FSR 0, FSR 1 and FSR 2, that hold the 12-bit address of the data registers or data memory and are used as pointers for the indirect addressing. Now to hold 8-bit address, FSR registers require 2 8-bit registers shown as FRSH and FRSL, and each FRS register is associated with INDF register for indirect addressing. We will see the details. Now various ways of using FRS register are as follows. First is addresses in FRS registers can be incremented before or after data transfer. So that is, we are incrementing the addresses before or after the data transfer. Then these registers can be decremented before the data transfer. This is another way. Decremented here before the data transfer. And third, addresses in FRS can also be offset by adding the contents of WREG, that is the working register. So the addresses of FRS are given below in the table. Now you can see FRS2, the address is FD9 to FDF, FRS1 FE1 to FE7, then FRS0 FE9 to FEF. So these are the addresses for the file select register. We will see in the diagram the file select registers. As you can see here, FRS2, the address is FD9 to FDF. So here we have the file select register to low byte, then high byte, then these are for the post increment or post decrement. So here we have the post increment pointer, post decrement pointer, pre increment pointer, and this is add WREG to FRS2. So if you look at this, addresses in FRS can be incremented before or after the data transfer. So for that we have 2 pointers. Then these registers can be decremented before the data transfer. We have another pointer for this. And then address in FRS can be offsetted by adding the contents of WREG. So here also we have another pointer. Then similarly we have the FRS1 and FRS0, the concerned registers. Now here each of the FRS registers, they have got indirect INDF2 here, INDF1 and INDF0, that is indirect file register pointer, that is for indirect addressing. So this is how the FRS registers will be used for pointing. Then next is program counter. The program counter or PC is a 21-bit register that counter and provides capability of addressing 2 MB of memory. So 2 raised to 21 is nothing but 2 MB of memory. So here we have three addresses for this program counter: FF9H, FFAH and FFBH. Then PC consists of three registers: PCL, PCH and PCU. The lower byte of the address 0 to 7 is stored in PCL. Then higher byte of the address 15 to 8 is stored in PCH, and the remaining bits, that is 20 to 16, 5 bits, they are stored in PCU. So this way it will have the 21 bits, and the MPU uses this counter to sequence the execution of instructions. That is the role of the program counter. Then the table pointer, stack pointer and stack. Now table pointer, these are 21-bit registers. So the address here is FF6H, FF7H and FF8H, that are used as memory pointers to copy bytes between program memory and data memory. So they are particular use, that is for copying the bytes from program memory and data memory. Then the stack. Now stack is group of 31 word size registers that are used for temporary storage of memory address during the execution of a program. Now these registers are neither part of program memory or nor data memory. Then to identify these 31 stack registers, we need 5-bit address and the stack pointer address. Say the stack pointer, it has got the address FFCH. So this register, stack pointer register, uses 5 bits to indicate where the addresses are stored. So if you look at the diagram, then it may be clear to you. Now see, here we have got the table pointers. These are the three addresses for the table pointers: FF6, FF7 and FF8. Table pointer, upper byte, higher byte and low byte. Then the program counter, we have got PC program counter low byte, then the another program counter high byte and the upper byte. So these three addresses FF9, A and B, they are used for the program counter. Then for stack pointer, now here we have got the first address FFC, that is for the stack pointer. Then these three addresses FFD, FFE and FFF, they are used for the top of the stack. This is low, high and upper. Since it is a 21-bit, so it requires three addresses for that. So these are the different registers. You can see this, all the registers are shown here, the PIC CPU registers. Then let us go to the next. They are the functional registers. Special function registers. The special function registers are registers associated with I/O ports, support devices and processes of data transfer. Now first let us see the I/O ports. There are 5 I/O ports A to E in PIC 18F452 or 4520 microcontroller, and these have been assigned the address F80 to F84, and these I/O ports are bidirectional and can be set up as input ports or output ports. The TRIS registers, that is the address is F92 to F96, are used to set up the I/O ports. Then next is interrupts. Now it has got 3 pins on port B that can be set up as interrupt request from external sources. The registers F9DH and F82 are used to enable the or disable the interrupts and set up priorities. So with the help of these registers, we can enable or disable the interrupts, and the port B 3 pins, they will be used as pins for the interrupt request. then EEPROM. Now these registers FA6 to FA9 are used to read from write to and erase EEPROM. So that is the separate memory in many of the PIC family microcontrollers. Then the next special function registers, we have the serial IO registers. Now here the address is FAB and FAF are used to set up the serial communication. They are specially used for the serial communication. Then timer registers, we have the microcontroller has 4 timers, timer 0 to timer 3, and the timer registers are used with the timer functions. Then next we have the CCP registers, that is capture, compare and PWM modules are set up by the CCP registers. So the address are FBA to FBF. They will perform the various functions required for the capture and compare. Then A to D converter. The PIC 18F452 includes the inputs for analog signals. Includes 4 inputs, actually this should be 4. 4 registers are associated with A to D conversion. The first 2 registers FC1 and FC2 are used to set up the various parameters for conversion, and remaining 2 FC3 and FC4 are used to save the converted reading. So the 4 registers are associated with the A to D conversion. Then we have the synchronous serial IO. The registers with address FC5 and FC9 are used for setting up various parameters of the serial communication. So again, these are different from this one. Then last is miscellaneous function register. Now the PIC 18F452 includes various features such as watchdog timer, low voltage detection and various oscillator options. These functions are set up using configuration register. So the address is FD1, FD2 and FD3. You can see the details of these registers. See, as you can see, FD say F80 to F84. These are the different ports: port A, port B, port C, port D and port D. Then FD9, F9D to F9F. These are for the interrupts. Then FA6, FA7, FA8, FA9. These are for the EEPROM. That is for read, write and other functions of the EEPROM. Then these are for the serial communication. And then for the CCP, we have got this register. Say capture, compare and PWM. These are the registers for FBA to FBF. You can see the addresses if you want. Capture FBA to FBH. Then these are the C1, C2, C3, C4. Again, they are the configuration registers. Then FC5 to FC9. They are again for the serial communication. And this FD1, FD2 and FD3. They are for the watchdog timer. Then the line detection and oscillator. So with this we come to the end of this video. If you like the video, please press the like button and share with your friends and subscribe to our channel Engineering and Technology Forum. And if you want to get notified, please press the bell icon, because whenever I would upload the videos, it will be available if you press this bell icon. Then if you have any questions regarding this topic, you can contact me on Facebook, Twitter, or my mail ulhaskumargokhale@gmail.com or Instagram. Then thanks for watching. Have a nice